In the vastness of the universe, some galaxies look familiar, spirals with their sweeping arms, or ellipticals with their smooth, glowing profiles, but every so often, astronomers stumble upon something so unusual that it does not quite fit any category. One of the best examples of this is Hoag's object, a galaxy so strange that when it was first discovered, even the astronomer who found it was not sure what he was looking at. The story begins in 1950, when astronomer Arthur Hoag spotted a curious object while studying stars and galaxies. What he saw was unlike anything else, a nearly perfect circular ring of stars wrapped around a faint, diffuse core. Hoag himself described it as a perfect halo. At first glance, it resembled a planetary nebula, a kind of glowing shell of gas left behind by a dying star. But its colors and position in the sky did not match that explanation. Hoag, puzzled, offered what he called a most conservative alternative. Maybe it was a pathological galaxy, a galaxy so unusual that it defied the normal categories astronomers were used to. One of the more exotic explanations suggested early on was that Hoag's object might be a gravitational lens, that the yellowish core was actually a massive foreground galaxy whose gravity bent and magnified the light of a background spiral, turning it into a perfect ring. Hoag himself considered this possibility, but later observations with more powerful telescopes revealed the truth. They showed the ring's detailed internal structure, individual star clusters, regions of differing brightness, features that could never be explained by lensing. The ring is real, made of stars, not a distorted image of something in the distance. Later studies revealed just how strange this system really is. At its heart lies a compact, round galactic core, about 5,000 light-years across, similar in properties to a small elliptical galaxy. Surrounding it is a massive ring of stars between 70,000 and 120,000 light-years in diameter. The ring is bright, blue, and full of young stars, in stark contrast to the older, yellowish stars in the core. And most mysteriously of all, between the two lies a striking gap, an almost empty void, like someone carved out the middle of a galaxy. Early spectroscopic studies showed that the core's light had a redshift, placing it about 600 million light-years away. The brightness and color of the ring indicated that it is bluer and more luminous than the core itself, suggesting active star formation. But when astronomers tried to look for signs of glowing gas in the ring, evidence of young, hot stars ionizing the gas around them, they found almost none. It seemed to be made almost entirely of stars, with little interstellar gas left behind. Astronomers have debated its origins for decades, and two leading hypotheses have emerged. The first points to bar instability. In many disk galaxies, including the Milky Way, the central regions can develop elongated structures known as stellar bars. These bars redistribute gas and stars through gravitational torques, funneling material both inward and outward. In extreme cases, the outer material may be pushed so far out that it forms a detached stellar ring. Some astronomers believe Hoag's object might have gone through just such a process. If its core once held a bar that later dissolved, it could have left behind a perfectly circular ring of stars detached from the center and separated by the empty gap we see today. But this idea comes with challenges. In most galaxies where bar instability plays a role, the resulting rings are imperfect, often asymmetric, warped, or connected by faint spiral arms. Hoag's object, by contrast, is almost too perfect, with a symmetry rarely seen in bar-driven systems. Moreover, there's little evidence that the core ever contained the kind of strong bar required to push material so far outward. If bar instability is the explanation, then Hoag's object seems to represent an extreme case, so extreme that it pushes the limits of the theory. The second hypothesis is more dramatic. a galactic collision. In this scenario, Hoag's object may once have been an ordinary galaxy until a smaller companion plunged straight through its heart. The shock of that passage would have sent a ripple through the galaxy's disk, driving gas and stars outward into a ring that later condensed into the brilliant blue circle we see today. Astronomers call such systems collisional ring galaxies, and examples like the Cartwheel galaxy show that this process can indeed produce structures eerily similar to Hoag's objects. Yet here too, the evidence is incomplete. If a smaller galaxy truly did collide with Hoag's object, we would expect to see some lingering trace, faint tidal streams, disrupted gas, or the remnants of the intruder galaxy itself. But deep observations with modern observatories have found nothing. The space around Hoag's object looks oddly undisturbed, almost too clean for a collision victim. And there's another puzzle. If the collision occurred billions of years ago, as the absence of an intruder might imply, then the stellar ring should have already dispersed. Collisional rings typically last only a few 100 million years before collapsing or fading away. Yet Hoag's object's ring remains sharp, luminous, and coherent, as though it formed more recently. Why it has endured so long, if it truly was born in a collision, remains unexplained. So both major hypotheses, bar instability and galactic collision, offer answers but raise equally deep questions. One struggles to explain Hoag's object's near-perfect symmetry, the other struggles to explain the lack of scars or debris. Neither is fully satisfying, which may be why Hoag's object continues to fascinate astronomers even today. Astronomers were so struck by its uniqueness that they eventually coined a term for galaxies like it, Hoag-type galaxies. A few others have been identified across the sky, but none shows the same striking symmetry and perfection. Hoag's object remains a prototype and the most beautiful example of its kind. What makes the image of Hoag's object even more fascinating is a hidden detail that often goes unnoticed. If you look closely, nestled in the background of the Hubble photograph, there lies a much smaller galaxy that seems to mirror the larger ringed structure. Its presence in the very same frame feels almost like a cosmic coincidence, as though the universe placed a miniature reflection of Hoag's object just behind it. Astronomers point out that this smaller galaxy is actually much farther away, simply aligned by chance in our line of sight. Yet the resemblance is uncanny. How is it that two such extraordinarily rare galaxies, nearly identical in form, ended up captured together in a single image? It feels less like a random alignment and more like a quiet echo written across the cosmos. Even now, more than 70 years after its discovery, Hoag's object defies easy explanation. Its symmetry is almost too precise, its survival too enduring, its origin still mysterious. It is one of the cosmos's final oddities, a galaxy that looks less like a product of chaotic evolution and more like a carefully crafted work of art. Thank you for watching PlanetSpiral. Please like this video and subscribe to this channel, and I will see you in the next one.